Thanks so much for coming, everyone. Coming out on early Saturday morning. This is very early in the morning for me, as you might imagine. An astronomer, I like to stay up all night and then go to bed when the sun comes up. But I'll try and stay awake. I've got some coffee here. I am just getting over a cold, but I think I can make it through. If I start to lose my voice, maybe we'll pump up the amplification so you can hear me a little better. So I am the director of the observatory and planetarium here on campus, which the astronomy department at Yale uses to teach astronomy, both in classes and also to school kids and also to the general public. And we open up the observatory every Tuesday night to the public. So if you'd like to come visit us up at the observatory, come on up Tuesday night. It's right up the hill on Prospect Street, 355 Prospect Street. And there's a great website, leitnerobservatory.org. If you go to this website, you can see what our planetarium shows are, what the events are that are coming up are. You can see if the sky's going to be clear or not, because if the skies are clear, we open up our telescopes for public viewing. We have wonderful telescopes up there. I'm going to talk all day, or for the next 40 minutes or so, about how telescopes work and what you can see with telescopes. So if you've never had the chance to look through a telescope, definitely come up on Tuesday night when the sky's clear. Even if the sky's not clear, we have planetarium shows at 7 o'clock and 8 o'clock. So this is our New Haven observatory and planetarium and place to go to learn about science, especially astronomy. What I'm going to tell you about today is what you can see through a telescope, how a telescope works, things like that. This image, this nebula up here is the Orion Nebula. It's a big cloud of gas, which is hot because it's in the process of making new stars. And we actually took this image using our telescope at the observatory here in New Haven. So you can actually do astronomy in New Haven even where you have lots of light pollution, and you can see some really amazing things. So who knows, who was the first person to use the telescope? Does anyone know? Do you know? Do you know who was the first person to use the telescope? No? Do you know? Galileo, exactly. And Galileo didn't invent the telescope, but he was the first person to use the telescope to look at the sky. And I happen to have a replica of the telescope that Galileo used. I'll talk about how it works, and you're welcome to, after the talk, come take a look at it. Maybe we'll take it to the back of the room, and we'll put a nice image of the moon or something on the screen, and you can do some indoor astronomy, as we call it, so you can see how the telescope works. OK, let's see how telescopes work. So what can you see through a telescope? Well, first of all, I should just talk about astronomers and telescopes and how astronomers use telescopes. This is probably the way most people think about astronomers using telescopes, or maybe something like this. You know, an astronomer setting up a telescope on a nice clear night, looking through, seeing the stars. Maybe it's a really, really big telescope, and he's looking through, and he's got a candle there and a little sketchbook, and he's sketching what he sees. This is the way astronomers did astronomy about 100 years ago. So we don't do astronomy this way anymore. So this is the way what we call amateur astronomers do astronomy. These are astronomers who are doing astronomy because they love it, because they just love to go outside and look at the sky using their eyeball, looking through a telescope, finding planets and finding nebulae and galaxies, and there's kind of a challenge of the hunt of finding new things that are even further and further away. That's really, really exciting. But it's a little bit different from the way professional astronomers work today. Professional astronomers almost never look through telescopes. It's kind of sad. Professional astronomers are just people who make a living doing astronomy. So that's really the only difference. Many of them love astronomy. All of them love astronomy, or they wouldn't do it. But usually they're trying to understand the physics of how a galaxy works, or the physics of how a planet formed, or maybe is there life on this planet. They're trying to figure out some science aspect of that. Whereas an amateur astronomer is doing it for the love of just looking at the sky and seeing all these amazing things, learning as much as they can. How many of you are amateur astronomers? You don't have to have a telescope to be an amateur astronomer. Just if you like to look at the sky and learn about astronomy, you're an amateur astronomer. So as I said, this is the way most people think of astronomers these days, and unfortunately, it's not really true. This one also isn't true. This is the way most people think. People who have read Harry Potter think this is what astronomy is, but unfortunately, it's a lot more mundane and boring. Rather than sitting in front of telescopes all night, what astronomers mostly do is sit in front of computers all day. So we write grant proposals, and we maybe get data from a telescope in Hawaii that's an image of a galaxy that's really far away, so that's really exciting. And we're trying to learn something about the galaxy. How far away is it? What is it made of? When did it form? How is it different from our galaxy? We're trying to figure out all those things on the computer, not at the telescope, because we got the data from the telescope the night before. So we sit at the computer, we figure this out, we write a paper, we send it to our colleagues. They say, you're crazy. That's not the way that galaxy formed. I think it formed this way. And it can be really exciting when you have a controversial new idea and you're trying it out with other people. But that's really more what astronomy is like today, much less like this or like this. I myself, I'm a radio astronomer, so I don't actually look through telescopes at all when I'm doing my astronomy research. I use telescopes that measure radio waves from other galaxies and from gas in the Milky Way galaxy and so forth. So maybe some of you have seen the movie Contact. It's a great movie with Jodie Foster in it. She actually discovers aliens using a signal from an alien civilization using a telescope in New Mexico. This is the telescope that I used to do my PhD research, and I still use it sometimes for my research. So it's a completely different kind of astronomy, and indeed astronomers are very different. They use lots of different kinds of light to study the universe, not just the light that you can see with your eye. So there are some X-ray astronomers and gamma-ray astronomers and infrared astronomers and radio astronomers and so forth. And we're all trying to figure out this big question of how does the universe work. But some of us still love doing amateur astronomy and love looking through telescopes. And that's one of the great privileges that I have running the observatory here in New Haven, is that I get to set up telescopes and go outside and show people the night sky and show people Saturn for the first time and show people the moon. And it's really, really wonderful. Amateur astronomers also, sometimes they form clubs, so they can get together and have star parties together where they go out all night with their telescopes and show people their telescopes. There's a great amateur astronomy club in New Haven. It's called the Astronomical Society of New Haven. And they meet up at the observatory on the last Tuesday of the month. So if you'd like to meet other amateur astronomers or learn more about amateur astronomy, you can find out about them. And they can set you up with a new telescope. They can show you how to use a telescope. They'll invite you to the star parties. There's all sorts of interesting amateur astronomy going on here in New Haven. OK, I want to talk about how telescopes work for a minute and then tell you what you can actually see through a telescope. That's why I call this talk The Universe in Your Hands, because a telescope really is like a spaceship. If I use a telescope that even if it only magnifies by 10 power, 10x, that's not very high magnification, making things look 10 times bigger. Even if I use a telescope that's only 10x, if I look at the moon, it's as if I'm 10 times closer to the moon. It's as if I've traveled 90% of the distance from here to the moon. If I use a telescope that's 100 power, which is pretty typical, most amateur telescopes use like 50 to 200x magnification and no more. There's no point in using more. If I use a telescope with 100x magnification and I look at the moon, it's like I've traveled 99% of the distance from here to the moon. And I see the moon as it would look if I were at that distance. So who was the first person to use telescopes for astronomy? Someone said Galileo. That's exactly right. It was 400 years ago, last year, in 1609, that Galileo used the telescope to look at the moon, and he made incredible new discoveries. This tends to be the case in astronomy. Anytime you build a new telescope and you think, oh, what are we going to look at? Well, just go look at everything, because you'll find something new no matter what you look at. And that was true for Galileo. So he looked at the moon, and he saw craters and mountains, things that people had never seen before. He looked at Jupiter, and he saw moons orbiting Jupiter, things that people had never seen before or even thought possible. So it's really amazing the things that you discover when you point a new telescope at the sky. Now, I should say Galileo did not invent the telescope. We're not really sure who invented the telescope. It's actually a very, very simple thing. It really is just two pieces of glass that are held in the right place to give you the right magnification. We know that people long before Galileo were using glass lenses to magnify light and to change the direction of light. So for example, here is an image. This is a painting from a church in Italy. And you see some monks that are studying. This is, these are the academics and the scholars of this time period, of the medieval time period. And one of these guys, let's let's see. One of these things is not like the other. One of these things just doesn't belong. So one of these guys is actually a little bit different. And it's not just he's wearing a funny hat. Let's see. Can you see that guy right there, what he's doing? He's wearing glasses, actually. This is the first representation we have of anyone using glasses to magnify what they're looking at or to change what they're looking at. So we know that as early as the 1300s, people were making glass into special shapes to do what we call optics, to change light, to change the magnification of light, and improve their vision. Here you can see that guy. These monks, of course, you know, they're sitting in their studies all day, copying out manuscripts. Their eyes go bad really fast. So this is a great advantage to be able to see more clearly when you're doing this work. So what Galileo did was he took two of these lenses that people had been using before for various types of optics, and he held them separated from each other. He had one lens that was a magnifying lens and another lens that was slightly different, that was the opposite of that. And if you hold them in just the right place, you end up seeing a very much magnified image of whatever the object is in the distance. So really, it's just two pieces of glass. So here is a magnifying glass. So simple magnifying glass, you can buy at an office store, at a department store. And what it actually will do is focus light. So that if I look at the light from the projector, or if I look at the light from the lamps overhead, I can make a little image of those lights. I could even do it out of my hand here. Never try this with the sun, by the way. But it makes a little focused, bright image underneath the lens. So what Galileo did was say, oh, I'm going to look at that image with another magnifier. And he invented the telescope. So I'll pass this around so you can try this out yourself. This is the lens in front, so just hold it out in front of your face. This is the magnifier that goes in front of your eye. This is, in fact, a real telescope eyepiece. This is not a real telescope lens. It's just a magnifying glass. But if you hold this up to your eye, everything looks blurry. Nothing's in focus. If you hold this lens in front, yeah. I see you back there. So try this out. Here you go. Just pass it around the room. It'll make it all the way around by the end of the talk. So last year was the 400th anniversary of Galileo's first use of the telescope for astronomy. And so we celebrated it as the International Year of Astronomy. And one of the things we did at the planetarium was commission an artist in Italy to make a telescope very, very similar to Galileo's. So this telescope I have in the front of the room is made using the same materials that Galileo might have used. It's made of wood and leather and very simple glue. Now the lens, though, that's at the front is much, much better than the lens that Galileo would have had. The lens that Galileo used would have been greenish, and it would have had bubbles in it. You know, imagine like an old wine bottle glass. Galileo didn't have access to really high-quality glass like we do today. But nevertheless, it still gives you a pretty good idea of what Galileo saw. Here is actually two of Galileo's actual telescopes that are on display on a museum in Italy. So if you go to Italy, you get a chance to see them. Now, we were very lucky last year. These telescopes went on tour, and they were actually in Philadelphia for a while. So we had the chance to examine them up close. One thing to notice about Galileo's telescope is that the opening at the end is very, very small. So the opening that lets the light in is very, very, very small. So that meant that the images that Galileo saw were very, very dim, unfortunately, compared to the telescopes that we can use today. But here's the basic idea. This is kind of a physics optics slide to show you exactly how this works. Two pieces of glass that have just the right shape. The lens in front, astronomers call that an objective. And all it is supposed to do is focus and gather light. So you're looking at something very faint. It actually concentrates the light beam so that it looks brighter to your eye. And that's very important because when you look at stars that are really far away, you want to see as much light as you can. You want to get all that light into your eyeball. Then the second piece of glass back here is just a magnifier. So this is what sends the light into your eyeball, and you can actually get a magnified image of the star that's floating in front of your face. All telescopes are just like this. It's really very, very simple. Just two pieces of glass that are held in just the right place. So last year for the International Year of Astronomy, there was a private organization that tried to make a very cheap, very simple telescope that we could get into the hands of lots of kids and teenagers and college students and people who may have never looked through a telescope before, but maybe could get their own telescope. And so they designed this telescope called the Galileo Scope. And it's very, very simple. The tube is made of plastic. You can take it apart. You can put it together. You actually make your own lenses. You put your lenses together. I can take it apart and show you the objective. So this is the objective. This is the lens that actually gathers all that light and makes the image in the front. It's a much, much better lens than that magnifying glass. It makes a much sharper, brighter image than that magnifying glass. So it's actually a very nice little telescope. We gave a few of them away at the planetarium, and I think they're still selling them at the Peabody Museum in the gift shop. So if you go over to the Peabody Museum gift shop, you may be able to pick one of these up. You can also go online. If you go to galileoscope.org, you can still order them online, and they're really, really nice. I'll pass this one around too so you can take a look at it. This is a really great first telescope. It lets you see all the things that Galileo saw 400 years ago, only much better. So what did Galileo see 400 years ago? What are the things that Galileo saw with his telescope? Well, after Galileo spent about a year looking at the sky with his telescope, he published a book. It was called Sidereus Nuncius in Latin, which means the starry messenger in English. And he published his drawings of the moon. Now, before Galileo, everyone thought the moon was perfectly smooth, that it was like an egg, like the surface of an egg, perfectly smooth. And Galileo saw, no, there are shadows. And it's a very rugged shape, especially where you go from night on the moon to day on the moon. That edge there where the sun is setting on the moon, you can see that it's just like mountains on the Earth, where the top of the mountain hits the sunlight first, and then the base of the mountain eventually comes into the sunset. You can see this for yourself with a Galileo scope or any small telescope. If you come up to the observatory on Tuesday night when the moon's out, you can definitely see this yourself. This is basically what it looks like. This is basically the same view that you get from that little telescope. So you see all the craters and the mountains very clearly here at the edge of night and day on the moon. Something else that Galileo did was he looked at the Milky Way. So people had noticed the Milky Way before, of course. You look up at the sky, you see this band of light going across the sky. How many of you have seen the Milky Way? Oh, most of you. I'm so happy. You can't really see the Milky Way in New Haven because of all the city lights. So I've never seen the Milky Way myself in New Haven. I think I saw it once in Branford when I was by the water and it was pretty dark. But if you want to get a really good view of the Milky Way, you have to go away from the city lights, look up. You'll see this band of light going across the sky. Before Galileo, no one really knew what it was. Galileo pointed his telescope at the Milky Way, and he realized that, oh, it's made up of stars. It's just thousands and thousands of faint stars that you can't see. They're not bright enough to see separately with your eye. But with the telescope, he could see, oh, it's just a bunch of faint stars. And that was a very big discovery. Probably the thing that Galileo is most famous for, though, is finding the moons around Jupiter. So here's Jupiter as seen through a telescope, and then here are the 4 moons that are named after Galileo, the Galilean moons. Does anyone know what their names are? Anyone know what the moons of Jupiter are? You can just say them if you know. Io is one. Europa, very good. Callisto, yes. There's one more. What's the other last one? Ganymede, yes, very good. So Io, Europa, Callisto, and Ganymede. They're very interesting places. They're actually more like the Earth or like the Earth's moon than they are like Jupiter. Jupiter is a big ball of gas. So it's very different from the Earth. But Io, Europa, Callisto, Ganymede, they're more like the Earth. And so we think that there's the water. We think that there's an ocean underneath the ice of Europa. So if we look elsewhere in the solar system for life, the moons of Jupiter are places we might go look and see, is there life elsewhere in the solar system, not just on the Earth? the big thing that Galileo discovered was that these moons go around Jupiter. So here's an actual part of, this is part of, drop this. This is actually part of Galileo's book. And here's the first drawing that he made in January of 1610 of Galileo and the moons. He said, oh, look, there are these two little stars that are on one side and one that's on the other side. That's interesting. But what was amazing was that he looked night after night after night. He kept looking at Jupiter, and he noticed that they moved around. So a couple nights later, he saw, oh, all three of them are on one side. That's interesting. And he watched night after night after night, and he could see them all orbiting around Jupiter. So that's an amazing discovery, because around the time of Galileo, everyone thought that everything in the solar system orbits the Earth. So that he saw these moons orbiting Jupiter was really new and interesting. Jupiter looks really neat through a telescope. There's a lot you can see. I purposefully showed you an image here of Jupiter as seen through a telescope, not a spacecraft. We now have amazing images, amazing photographs of Jupiter taken by the Galileo spacecraft and by other spacecraft, the Voyager spacecraft. But this is what Jupiter looks like through a telescope at the observatory or a typical telescope. You can see the cloud bands on Jupiter. And something that Galileo noticed was that there's a spot on Jupiter that seems to stay there all the time. This is a huge hurricane about 4 times the size of the Earth that's been blowing for at least 400 years on Jupiter. Galileo also looked at Saturn. And you know, what's Saturn famous for? The rings, of course. If you look at Saturn through a telescope, even a telescope here in New Haven where the sky isn't very dark or very sharp, you can still clearly see the rings. And if it's a very good night, you might even see that there's a gap in the rings, and you may see some of the clouds on Saturn as well. Galileo looked at Saturn, but his telescope wasn't quite good enough to see the rings separately. He thought that Saturn had ears, basically. So here's Galileo's drawing of Saturn. He thought maybe there were moons that were always in the same place around Saturn. So he didn't quite discover the rings of Saturn, but he saw that there was something funny about Saturn. Saturn is one of my favorite things to look at through a telescope because it always looks really, really good, even if the sky isn't very clear. Saturn is up really early in the morning this time of year. So if you want to see Saturn, you have to go out at like 2, 3 a.m. in order to see it. But Jupiter is really well placed now. If you come up to the observatory on a Tuesday night this fall, I guarantee you'll get a chance to see Jupiter. I can just show you, actually. Here's the sky tonight. This is a planetarium program. And here's the sky tonight right at sunset. And you see Mars and Venus are setting in the west right at sunset. So if we go back a little bit in time, you see there's Venus. There's the sun. You see Saturn is over towards the sun, so you have to get up really early in the morning to see it. There's Venus, Mars, and now it's dark, so now it's about 8:30. And if we look over to the east and southeast, there's Jupiter right there. Now, it also turns out that Uranus is very close to Jupiter right now as well. So you have the chance of seeing Uranus through a telescope this time of year as well. So come on up to the observatory on a Tuesday night. Take a look at Jupiter through our telescopes. But if you get your own telescope, and it doesn't even have to be a very big one, just one of these small Galileo scopes is certainly good enough to see the moons of Jupiter. An amazing discovery you can make for yourself is that the moons of Jupiter are going around Jupiter. That's what Galileo saw. One more really important thing that Galileo saw was when he looked at Venus, he saw that Venus wasn't a perfect ball. It wasn't always perfectly lit up. It went through phases just like the moon does. So sometimes Venus is a crescent like the moon. Sometimes it's half illuminated like the moon. Sometimes it's almost fully illuminated like the moon. And what Galileo realized was that this proved that Venus goes around the sun. Now, that's really obvious to us. All the planets go around the sun. But remember, when Galileo was alive 400 years ago, most people thought that Venus goes around the Earth, and the sun goes around the Earth, and Jupiter goes around the Earth. They thought that the Earth was the center of the solar system, and everything went around the Earth. Galileo proved, no, Venus is clearly going around the sun, because sometimes we see it as a crescent, sometimes we see it half, sometimes we see it full, And that only works if you have Venus going around the sun. So this is amazing proof that the Earth is not the center of the universe. All of these things you can see for yourself with a very small telescope. You don't need a fancy $5,000, $10,000 telescope. You can get a pair of binoculars that have at least about 20 or 15 magnification, or one of the Galileo scopes, and you can see this for yourself. OK. Well, there are different kinds of telescopes. Galileo invented a telescope that used a lens. So like this, where you have a lens at the front and you have a lens at the back. But there are other ways of making telescopes. There are other ways of gathering and focusing the light. Here's one of these big telescopes. They're called refracting telescopes because they have lenses. This is the biggest one that was ever made. You see a person standing right there. It's in Wisconsin. It's a few hours north of Chicago in Wisconsin. And you see how long it is. The lens at the front is about a yard across. There it is. That's the lens at the front. Really, really, really big lens. When you start making lenses this big, the glass starts to sag in the middle, and all sorts of problems start to happen. You also get this problem with the lens that the light will not focus properly. You'll actually see little rainbows around the light. This very, very simple telescope that I passed around with the magnifying glass, when it comes around to you, you may notice that when you look through it, everything is little rainbows. So lenses will actually do this. It'll turn things into little rainbows. Well, about 100 years after Galileo, Isaac Newton came up with a new way of making telescopes that used mirrors instead of lenses. So he realized that if you use a mirror instead of a lens to focus the light, you solve a lot of problems. And you can make the mirror really, really, really big. So most of the new telescopes that are built today use mirrors instead of lenses. So this is another telescope that was built for the year of astronomy last year. It's made by a company called Celestron. It's not very expensive. You can buy it online for maybe $50 or so. And it's a nice telescope for looking at the moon and Jupiter and Saturn and so forth. But instead of having a lens at the front, it has a mirror at the back. So it's a completely different kind of optics. This type of telescope was invented by Isaac Newton in 1668. And it has a mirror in the back and an opening at the front. And the light comes out sideways here. That's where you put your eyepiece and you see the magnified image. Here's the diagram of how that works. So it's very important that you have that little mirror inside to send the light out sideways. Otherwise, you'd have to put your eyeball in the middle of the beam here, and then you block the light coming in. So this little mirror right here, it does block some of the light, but it doesn't block very much of the light, and the light goes out sideways. And you look in at 90 degrees in order to see what you're focusing on, in order to see the stars, or in order to see Saturn. So this is a very simple little reflecting telescope. This is the kind of telescope we use up at the observatory to do our research projects and our student lab projects. And I'll pass this one around as well, and look inside and see the mirror and see the second mirror at the front. This one is a little bit more sensitive to donut crumbs. So don't put your fingers inside the telescope. Just look and see. If you're in the very back of the room, you may be able to look in the eyepiece and focus on what I've got up at the screen. If you're in the front, you may be too close. It probably won't focus. The way we focus the telescope is by turning this knob, which makes the eyepiece go further in and out, and that changes where you're focused. These telescopes are called Newtonian telescopes after Isaac Newton. And these are very popular telescopes with amateur astronomers because you can get a telescope with a really big mirror for not very much money. In terms of how much you pay for it, you get a lot of light gathering power. In fact, sometimes astronomers call these big telescopes with mirrors, they call them light buckets because they're big enough that you get a huge amount of light coming into your telescope. Here's an even bigger one that amateur astronomers use. Here's an even bigger one. This is a research telescope. This is the Wisconsin-Indiana-Yale Telescope, which is in Arizona. So this is one of the telescopes that we use for research at Yale, for astronomy research at Yale. Its mirror is 3.5 meters across. So it's actually a very, very big mirror back here in the back. That mirror that's going around is only about 70 millimeters or so across. So it's a much, much smaller telescope. You want your telescope to have as big a mirror as possible because that's how you're going to see the faintest, most distant objects. So the bigger the mirror, the more light you're going to intercept, the more light you're going to focus, and the fainter you can see. That's really, really important. In fact, that's the most important thing about a telescope is how big is what we call the aperture. How big is the lens, or how big is the mirror, right? Galileo's telescope, you can see, has an aperture, has a lens that's only about 1 inch across. So he couldn't see very faint objects. He could see the moon, he could see Jupiter, he could kind of see Saturn, but he wasn't going to see other galaxies, he wasn't going to see nebulae. Those are much too faint. You need a bigger telescope in order to see these things. So when you go to shop for a telescope, if you're thinking about buying a new telescope, sometimes they'll say, oh, this telescope magnifies 1,000 times, or 10,000 times, or some enormous, huge number. Well, you don't care about that. You don't care at all. Any telescope can magnify by any amount. You just have to change the eyepiece. What matters is how big is the mirror, or how big is the lens. The bigger the lens, the bigger the mirror, the fainter you'll be able to see, the objects that you'll be able to see. That's why professional telescopes we use for research are so big. We're looking at galaxies and quasars and the edge of the universe really far away. We need really, really big telescopes. The biggest telescopes we actually put up on mountains far away from cities, so we have the darkest skies and the sharpest images. So this telescope right here is the Gemini Telescope. It's in Hawaii, on top of Mauna Kea in Hawaii. You can go visit it. It's actually paid for by you. If you pay taxes, you pay for it. So it's a nationally funded instrument. It's not some super rich guy uses it for his own pleasure or whatever. It's not universally run only. It's paid for by the National Science Foundation and the US taxpayers, and anyone can put in a proposal to use it. So if you have an idea for what you'd like to do with this telescope, write out a proposal to the National Science Foundation and send it in, and they'll consider whether or not you can use their telescope. If you have a really good idea, they might give you time. Here's what it looks like. It's a really, really big telescope. The mirror is 27 feet across. There you see the mirror right there. And it's hard to compare. You know, this could just be a model, a toy model. But there's a person. There are two people standing right there. So there you can see the size of that mirror all the way across. Compare that with the little 70-millimeter telescope that I passed around. This is a much, much, much more sensitive telescope. OK. Now, I just said that we put these telescopes on mountains far away from cities. And a big part of the reason why we do that is because of something called light pollution. So if you build this big observatory that you're going to use to study the universe, you want to get the sharpest images you can and see the faintest objects that you can. So you don't want to have city lights near your telescope that make it hard to see. Now, we have a lot of problem with this in New Haven. Here's kind of the New Haven skyline, and you can see all these lights at Yale University and in the city and so forth. And on the one hand, we definitely want to have lights so that it's safe to walk around at night and so you can see where you're going and so forth. But on the other hand, it really hurts what we can see in astronomy. So here are two pictures of the Milky Way. It's a little bit easier to see over here. You see the Milky Way right there. There's a house. Here's the house with all of its lights turned on, and the light pollution makes the Milky Way go away completely. So when we can limit the amount of light pollution, if we can do it with still making it safe, then we want to do that. In fact, it's kind of a way of saving energy. You know, we're all worried now about greenhouse gases and global warming and pollution going into the atmosphere and so forth, and we want to conserve energy as much as we can. And in fact, light pollution is a big waste of energy. All this light just goes up into the sky, and it makes it worse for astronomy, and it just wastes a lot of energy. You see, we're really, really bad here on the East Coast. Back over here in the mountain states, they have it a little bit darker, but we have a huge amount of light pollution over here. Especially if you zoom in here on New England, you can see, well, New Haven is not in the worst place for astronomy. That might be New York, but it's pretty bad. If you really want to see the Milky Way and see a dark sky, you kind of have to go up into Vermont or New Hampshire. Now, we do have an observatory at Bethany Observatory near Bethany, Connecticut. Have any of you been there before or heard of it before? Yeah, the amateur society, the amateur astronomy group in New Haven, sometimes they have star parties and classes and things. But there is an observatory in Bethany where it's a little bit darker, a little bit better for astronomy. But we have it really bad in New Haven. Now, what can we do to make things better? Well, a lot of the lights around campus at Yale or in the city, they don't try and make the light come down to where you're looking. The light just goes up into the sky. So if you have a light fixture like this, the light's just going up into the sky and lighting up the astronauts, and they don't really care. They don't really want to see all that light. Here's another example of really bad wasted energy, wasted light pollution. Some billboard that's vacant for now, and they never bothered to turn off the lights that light up the billboard, so we're advertising blank space. I guess this is like an advertisement for Zen Buddhism or something. I don't know, but just think of that. All that energy being wasted. So if we install lights that are shielded so that the light comes down to what you're looking at instead of going up into the sky, it'll be much, much better for astronomy. So these lights that are shielded on the top makes it easier to see the sky, and it saves a lot of energy. They seem to be better at this in Europe. This is an image of a highway in England, and you can see the lights are shining down onto the highway. It's kind of a foggy night, so you can see the cone of light coming down. And there's really not much light going up into the sky. So we need to get better at this too, so that we have better astronomy and save energy as well. OK. Well, the last thing that I want to talk about is things that you can see through a telescope that Galileo didn't see. So you do need a little bit of a bigger telescope in order to see these things. But again, if you come up to our observatory on a Tuesday night, you can see some of these things through our telescopes. So even where we have light pollution in New Haven, something we like to look at are double stars. These are stars which are orbiting around each other. Of course, the sun isn't a double star. We just have one star in our solar system. But some star systems have two stars or even more stars orbiting around each other. And this is one of my favorite double stars. It's called Albireo. It's in the constellation of Cygnus. And it's two stars next to each other that are different colors. You don't think usually of stars as having really bright colors. You look up at the sky and you think, oh, the stars are so pretty, but they're basically white. But if you magnify a star and collect a lot of light to look at it, then you can see, oh, no, it does have a kind of a bluish color or a little bit of a reddish color or a yellowish color, something like that. And stars do really have colors, and you can see that through a telescope. It's really very striking with these two stars because of they're so bright and they're right next to each other. Now, why do the stars have different colors? Why should stars have different colors? Does anyone know? Do you know? There might be different gases, but they're all made of hydrogen. Almost all stars are made of hydrogen. What else? How hot it is. That's exactly right. So which star do you think is hotter, this one or this one? The blue one or the red one? Which one do you think is hotter? Yeah? You think the yellow one is hotter? That might make sense. The blue one. So how many people think the blue one's hotter? How many people think the red one is hotter? Oh, a few people. OK. Well, if you heat something up and it glows because it's hot, first it glows kind of red hot, and then kind of yellow hot, and then maybe white hot. And then if you can get it really, really hot, it might start to glow bluish hot. So actually, that's right. Something that's glowing because it's hot, it will tend to glow bluish if it's really, really, really hot, like a really hot star. And if it's not so hot, it might glow reddish. Now, red hot is still hot. But red hot is not as hot as blue hot. So astronomers are always confused. We go to the sink and we want hot water, and there's a blue faucet and a red faucet. And we turn the blue faucet, and cold water comes out. That doesn't make any sense. Yeah, this star is hotter, much, much hotter. A blue flame is hotter than a red flame. So this star is much, much hotter than that star. When we look at star clusters with our telescope, sometimes we see colors. And that's because they're different temperatures. These are all very young, massive stars that are really, really hot, and they have kind of a bluish tinge. Now, they're not bright blue. They're not sky blue. It's kind of blue-white. It's kind of like Easter egg colors, pastel blue. And this one's kind of yellowish. So these blue stars are much, much hotter than that star right there, which is a red giant star. Here's another double star we like to look at our observatory. This is my second favorite double star, which is actually a quadruple star. So if you look at it with your eye, you see, oh, look at that pretty star. It's just one star. The star has the name Epsilon Lyrae. You zoom in with a telescope and you say, oh, wait, no, it's two stars. They're orbiting around each other, two stars. And then you zoom in even more, and you see, oh no, it's 4 stars. It's 2 pairs of stars. These stars are doing a do-si-do around each other, and these stars are doing a do-si-do around each other, and then each pair is going around each other around their common center of mass. So they're doing this complicated square dance around each other, which is really cool. Sometimes we look at these star clusters with our telescope, so you would be able to see this with a small telescope as well. Star clusters are really, really beautiful in a small telescope. These are groups of stars that have fairly recently formed from gas in the Milky Way, and they're all at about the same distance. So they're all in this nice little tight cluster. The sun used to be in one of these clusters too, but over time we drifted away. Here's another one. This one's an older, denser star cluster. A lot of these objects, I put the name of these objects. You can see this is M11, the wild duck cluster. This is M13, the Hercules cluster, and so forth. You see a lot of them have M and then a number. These are named after astronomer Charles Messier, who was a French astronomer who wanted to become famous. And how do astronomers become famous? Well, these days, I guess you have to win the Nobel Prize, or you have to have a TV show like Carl Sagan or something like that. There aren't that many famous astronomers right now. But in these days, back then, if you wanted to become famous, what you had to do was discover a comet. So Charles Messier really wanted to discover a comet. And he would go out every night to his observatory with his 6-inch telescope, and he'd scan the skies looking for comets. And comets are basically little fuzzy things in the sky, and night after night they move relative to the stars. So he'd scan the sky, and he'd see, oh, a fuzzy thing, and he'd write it down. He'd go back the next night and say, oh, it's still there. Write it down. Oh, it's still there. I guess it's not a comet. It's not moving around relative to the stars, because the comets are orbiting the sun just like the planets are. So Charles Messier wrote down a list of fuzzy things in the sky that are not comets. And now we call them the Messier objects. And they're mostly star clusters and nebulae and galaxies and things like that. So M13 was the 13th object that Messier wrote down in his list that wasn't a comet. Well, he did actually find comets. He was a diligent astronomer. He found 6 comets in his lifetime. But we don't remember him for that now. He's not famous for the comets. He's famous for these things that he wrote down that aren't comets. But all of these objects are really nice to look at through a small telescope. They're all very pretty. Now, through a really small telescope like the Galileo Scope, if you look at a nebula, it might just look like a little fuzzy ball. You need a slightly bigger telescope to see some detail. But for example, here's a nebula called the Dumbbell Nebula. And again, this is an image from our telescope up at the Lightner Observatory. You can see the colors. You can see this big fuzzy ball. This is the shell of a star that's died. So this is what the sun's going to look like in about 6 billion years. When the core of the sun collapses, the outer layers expand to make a big nebula. This is what it's going to look like. Here's another one. This is M20, the Trifid Nebula. This is a place where stars are forming. So you get gas clouds in places where new stars are forming or where stars are dying. Because stars are made of gas, of course. Stars will attract in gas by their gravity. The star will live for billions of years, maybe, and then it will die and push the gas back out, and it will eventually make new stars. So stars recycle. They're very good that way. Here's another one. This is the Eagle Nebula. It's a little bit easier to see up on that screen. This is one of my favorite nebulae. This is called the Ring Nebula. Looks just like what it's called, fortunately. This is another one of these nebulae where the star has died. The core of the star has collapsed to make this thing called a white dwarf. There it is right there, the white dwarf. The outer layers have expanded off to make this shell of gas, which is very hot, and it's expanding and cooling. And maybe someday in the future, it's going to make, this gas will make a new star sometime in the future in a few billion years. Now, whenever we have a public night up at the observatory, someone will say, oh, I want to look at a galaxy. Let's look at a galaxy. This is the Andromeda Galaxy, which is the closest galaxy to us. Galaxies are whole islands of stars that are their own separate thing. Every star that you see here in the sky in this image is in our galaxy, and the Andromeda Galaxy is in the background. It's 2 million light years away. So it's many, many, many times further away than these stars that you can see in the foreground. Well, galaxies are so far away that they're very dim. They're very hard to see, especially if you have a sky that's kind of bright from light pollution. So I have to tell people galaxies don't look like this in a small telescope. So you go and you shop for a telescope at Walmart or Target or at an optics store or a camera store or whatever, or online or whatever, and the box will have pictures like this. on the box. And I can't tell you, I shudder to think at the number of people who've been scared away from astronomy because they look at this on the box, and they get their telescope out and they point it at the sky, and they don't see this. Right? This is an image which was taken by a big telescope with a long exposure with a digital camera. And we can make pictures like this using our telescope, but it takes a lot of work. You just can't look through the telescope and see this. This is what galaxies look like through a telescope. This is a sketch someone did of the Andromeda Galaxy through a telescope. You tend to see a little fuzzy ball of light, and you might see a little bit of light from the disk of the galaxy kind of extending out. And if the galaxy has satellite galaxies, you may see those as well. It's a very subtle experience. It's not as exciting as seeing the moon or Saturn or Jupiter through a telescope. Those are the things I recommend you look at first. Saturn, the things that Galileo looked at that look amazing. The moon, Jupiter, Saturn, and so forth. Star clusters, double stars. Once you get more advanced, then it is very rewarding to go hunt down these galaxies and look at them with your eye and maybe even take a picture. It's not that hard to take pictures of things through the telescope. So here's another famous galaxy, the Whirlpool Galaxy. And it just looks like a fuzzy thing. You might be able to see a little bit of the spiral arms when you look at it through an eyepiece. So don't get your hopes up about looking at galaxies. OK. Actually, one last thing that I do want to talk about before I finish up today, and that's how professional astronomers use telescopes as well. So we don't use the small telescopes to do our research because we need really, really big telescopes to see the faintest objects. But we also want to have a really sharp image of what we're looking at. And unfortunately, we're looking through the atmosphere, which is very turbulent and has a lot of storms and wind and so forth, and it makes the images not very sharp. So a new technique that astronomers are using with telescopes is something called adaptive optics. We can shoot a laser beam up into the sky and measure how the atmosphere is twinkling, and then we can change our telescope to remove the twinkling. So whereas with our telescope, you might see just a blob of light, when you turn on the laser, you see, oh, there are actually two stars there that are right next to each other. You get a much, much sharper view. So for example, the Keck telescope in Hawaii can look at Uranus and Neptune and make a kind of a blurry image. This is Uranus. Did you know Uranus has rings? Uranus has, all the outer planets have rings. Jupiter, Saturn, Uranus, and Neptune. They all have rings. But Saturns are coated with ice, so they're very shiny. You can see them very easily. You need a much bigger telescope to see the rings of Uranus. But here's the blurry view, and then here's the sharp view. And here's the blurry view of Uranus, and then here's the sharp view. So that lets us see a lot more than we'd be able to see just looking through the atmosphere. This is why the Hubble Space Telescope images are so great. Sometimes people think Hubble's a great telescope because it's closer to galaxies and the planets and the nebulae. Well, it's only about 100 miles up, maybe 200 miles up above the Earth's surface. That's not very much closer compared to millions of light years, right? But what Hubble does is it gets above the sea of the atmosphere, above the turbulent twinkling of the atmosphere. So that gives us much, much, much sharper images. For example, this is an image of a nebula called the Eagle Nebula. You see it a little bit better up there. See that red light, that glowing red light there. And then here's a star cluster right next to it. It's the Eagle Nebula. If I zoom in on part of it, you see there's kind of a dust cloud right there and a dust cloud right there. And you see those two stars right there. Now, this is what it looks like from New Haven. This is what it looks like from the Hubble Space Telescope, right? It's the same part of the sky. These two, that star right there and that star right there, those are the same as that star and that star, or that star and that star. And now you can see all of these little gas clouds, all these little dust clouds, and all these new little stars that are forming in this cloud of gas. So it tells us so much more about what's going on if we have a much, much sharper view. I showed you the Ring Nebula before. Here's our view from New Haven. It's very pretty. It's very beautiful, very colorful. If we look at it with the Hubble Space Telescope, we see so much more detail. We see all these little clouds of gas and dust, and we can see the star in the middle really sharply. So that's really, really important. I also mentioned that it's really important for us to use other types of light. So infrared light. It's really important for us to study galaxies and nebulae and so forth using infrared telescopes if we can. So here are some astronomers. You see their telescope over there, and they're using an infrared camera. They're taking just a group photo right now, and you can see what these people look like in infrared light. We think of it as heat light because something that's warm will emit infrared radiation. But stars and galaxies will also emit infrared light. You have to put a telescope in space in order to see it. But for example, here's an image of the Whirlpool galaxy I showed you before. There are all the stars, and now here's all the warm gas and dust that's emitting infrared radiation. It's kind of like night vision goggles. We can see all of this stuff that we couldn't see before with the infrared telescope. OK, actually, I think I will finish up there. My last 2 slides, I just want to show you, if you're interested in buying a telescope or thinking about buying a telescope, a really great telescope to start with is actually just a pair of binoculars. If you get at least 15 power, you'll be able to see a lot of the things Galileo saw, the craters on the moon and the moons of Jupiter and so forth. You won't be able to see the nebulae as sharply as with a telescope, but they're very easy to use. They're not very expensive. You can go and sit out on a lawn chair and sit back and just scan the sky back and forth. In fact, people today who look for comets, sometimes they'll just use really big binoculars, and they'll just scan the sky back and forth. So these are binoculars made for astronomy. The front of the aperture, the lens size is 70 millimeters, and the magnification is 15 power. And they're really, really nice for getting into astronomy, learning where these star clusters are, learning the constellations. It's really, really nice. When you become a little more advanced, a good telescope to start with is one of these Newtonian telescopes. This is one made by a company called Orion. And they're about $200 or so, has a 6-inch diameter mirror, and they're really, really nice for looking at star clusters and double stars and the moon and so forth, and it's a great way to get started. OK, well, I hope you enjoyed that, me talking about telescopes. If you'd like to check out my Galileo replica telescope, please feel free to come on down, and have a great day.